Okay, what we're going to be doing in section 1 here is looking at nth roots of integers, So we've got kind of a rule right off the bat here, and we're looking at something like, well, let's just look at a quick example. Let's say that I've got, the fourth root of 2. Okay, this would be the nth root of the number 2. And so we're just looking for basically what number multiplies together 4 times that gives us 2. Okay, it's a lot like looking for a square root. If we're looking for a square root of 4, we're looking for an nth root of 4, and that n just happens to be a 2. Okay, so we'll look at some examples here. It's not horrible, but it's a little bit different than what you're used to. And so what we're going to do is we're going to let n be an integer, and it's got to be larger than 1. That's what we're going to work with. And we're going to let it be a real number, so no imaginary numbers right now. And then what we're going to do is we're going to say that if n is even, so if n is an even number, then we're going to have if a is less than 0, if our number is less than 0, we have no real roots. And if n is at even integer and a is equal to 0, then we have one root. And if a is greater than 0, we have 2 nth real roots. We have a plus version and a minus version. Okay. If n is going to be odd, then we have kind of all the same things, except now we're guaranteed basically one real nth root the whole way through. And so, oh, and by the way, on this guy right here, this is positive versions only, not plus and minus, just positive versions only. Okay, so so that's kind of your rules and kind of your setups on these things. They're not too bad. But for example, let's look down here. If n is 3 and a is negative 216, so I'm looking for the cube root of negative 216. Okay, well, n is odd, so I'm looking on this side right here. And my number a is negative 216, so it's less than 0. So how many real roots do I have? Well, I think about the things that all multiply together that make 216. Well, what are they? Another way to think about this, another way to write it is negative 216 to the 1/3 power. Well, what times what times what? 3 times makes 216. Well, just run a quick factor tree. And let's think of numbers that go into 216. And I'm looking at 216, and it's divisible by 2 and 3. So I'm going to do a 6 here, and that gives me 36. And then when I do this side, I get a 6 again. And remember, we're looking for cube roots. So cube root means we have to have 3 to bring out 1. Well, look, I've got 3 6s. And so what that's going to tell me then is that the cube root of 216, is 6. And since the number's negative, I'm going to have a negative number with it, negative a value. So what is my answer here? My answer for this is going to be negative 6. That's the cube root of negative 216. All right, look at over here at this other guy. We've got n equal to 4, so we're looking at a 4th root. And then 81 goes on the inside, so we're going to follow. Now we're going to follow this side over here. So think about the things that go into 81, which can also, this number can be rewritten as 81 to the 1/4 power. Okay, this is another way that it can be shown. And so we just think, okay, factor tree it out. What times what times what is 81? Well, that's going to be 9 times 9 is the easiest thing to see, and then 3 times 3. And since we're dealing with a 4th root, then I need 4 to take 1 out? Well, I've got 4 3's right here. So what does this equal? The fourth root of 81 is equal to 3. But it's also equal to -3 because you see, I fall into this category right here. My a value in this case is 81. It's larger than 0. So I have 2 real nth roots, a plus version and a minus version. So it just looks a little bit different. It just requires a little bit of thought. But let's come back up here and revisit our square root. Like our square root requires us to have 2 2's to bring the 1 out. The square root of 2 is 4. Or the square root of 4 is 2, but why is that? Because when I factor out 4, I've got 2 2's. So if I'm looking for the cube root of something or the fourth root of something, that tells me how many items of one thing at a time I need to just bring one of those numbers out. So it's not horribly difficult, but it is something that you have to pay attention to. Okay, so with rational exponents, there's a few rules that we need to be aware of that'll just make life easier for you. And the quicker you can get to these into your head, the easier life will be. The first one is this guy right here, that this top power, that top power right there, that guy is, he's a power. Okay, and it tells you, that top guy tells you, hey, this is the power that we're going to raise up to. So I've got an m on for my power, and that's what I pick, okay, for my power. My root is the bottom number right down here. This guy's my root. So if the top number of the fraction is my power, the bottom number is my root, and it ends up looking like this guy right here, okay? So if I've got m over n, m is the power, n is the root, all right? If I have negative m over n, then it's just the reciprocal, just like all our other exponent rules, it's just going to end up being the reciprocal. So we move this guy then to the denominator, and when we do that, we're going to end up with a to the 1 over n to the m, which again is the same thing that we got off the first guy, except now he's in the denominator instead of the numerator. So you end up with this whole fraction instead. It's not it's not horribly painful. Don't let this be painful. Just remember, the top number, the numerator is the power, the denominator is the root. So if I'm looking at down here at this guy, 16 to the 3 halves, I'm looking at the square root of 16 cubed. Well, the square root of 16 is 4, so I'm actually looking at the number 4 cubed, and 4 cubed is 64. Not too bad. Not too bad at all. Just go one step at a time until you're done. Well, if I've got 32 to the negative 3/5, that's exactly like the second part we're looking at. This is actually going to be 1 over 32 to the 3/5. So I'm actually working this problem right here. Well, what does that mean? That means that we're going to have 1 over the 5th root of 32 cubed. And hey, you know what? Doing these rational exponents, they can be a little bit tough. And so I don't know what the 5th root of 32 is off the top of my head. So what I'm going to do is just sort it out until I get all the way down to the end, and then I'll look at what my numbers are. So I'm going to have 8 and 4, 2 and 2, 2 and 4, and 2 and 2, and I'm looking for 5th root, which means I have to have 5 numbers to pull one out. Well, looky here. Look what I've got now. I've got 1, 2, 3, 4, 5 2's. I've got 5 2's. What does that mean? That means that I'm going to end up over here with 1 over 2 cubed, which is 1 over 8. So don't let this be hard. It takes a little bit of practice, but really once you get your practice going and you've worked a few of these problems, they're really not too bad. The whole trick here is to remember that your power is in the top, your root is in the bottom. Okay, so we're going to solve some problems using nth roots, and to do that, the biggest thing is that we want to get the x all by itself, and there's kind of two different ways to solve this, so we're just going to divide these into half here. And when we're looking over here on the left, if I've got 4x to the fifth is equal to 128, what I want to do is divide both sides by 4 so that I have the x all alone and by itself. And when I do that, I get x to the fifth equals 32. Okay, and then once I get x to the fifth equals 32, what I'm going to do is take the fifth root of both sides. And the reason I choose the fifth root is because x to the fifth root of x to the fifth is just x. And this is totally legal because whatever I do to one side, I do to the other. And so I'm just going to take this x to the fifth and I'm going to do it again, but I'm going to do it to the right-hand side of the equation as well. So it looks like this. And we just saw in our previous problem that the fifth root of 32 is 2. So not too bad, not too bad at all. This is something that we can handle. Well, what about the other side? X minus 3 to the fourth is equal to 21. Well, hey, that's a tough question. And, you know, I don't want to really have to multiply out x minus 3 to the fourth power, solve it all down, and try and look for places that it crosses the x-axis. That's a lot of work. The simplest thing is to get these parentheses all by themselves. And the way that I'm going to do that is I'm just going to go ahead and take the fourth root of both sides. The fourth root of x minus 3 to the fourth is going to be x minus 3. And then I'll also take the fourth root of 21. So this is going to get me x minus 3 equals, and then keep in mind here that we could have plus or minus the fourth root. This goes back to the very first problem that we worked. We're looking at an even root, and we're looking at a number larger than 0. So this could be plus or minus the fourth root of 21, and then just add 3 to both sides. And looky here, the x is all by itself. We didn't have to do a ton of math. We didn't have to panic. You know, we didn't need to phone a friend, and we've got our answer: 3 plus or minus the fourth root of 21. And that's all there is to it, and that's an exact answer, and that's an answer that you're going to see in a lot of places. Now, if you're looking for a decimal, we can still find this decimal on your calculator. It would just be 3 plus 21 to the 1/4 power, or 3 minus 21 to the 1/4 power. And that's how you can find this guy on your calculator. So it's really a handy deal. It's not hard. Don't let it be hard. But you can do this. You can work this out.